Hello and welcome to Astronomy Daily, your daily guide to the cosmos.
Where we explore the latest breakthroughs and biggest stories from the world of space and astronomy. I'm Avery.
And I'm Anna. It's great to have you with us. We have an absolutely stellar lineup for you today.
We certainly do. We'll be visiting the distant ice giant Uranus, which has a brand new moon. We'll also be exploring the lonely lives of rogue planets, which it turns out might not be so lonely after all.
Plus, a tale of two sibling asteroids that could hold clues to the origin of life. And we'll be chasing the famous Devil Comet to find out if it's responsible for the water in our oceans.
It's a packed show, so let's jump right in.
Our first story takes us out to the seventh planet from the sun. The solar system's family portrait has a new addition as astronomers have officially confirmed the discovery of a new moon orbiting Uranus.
That is fantastic news. It feels like the outer planets are the final frontier of our own solar system. It's amazing to think we're still finding new members out there. What do we know about this newcomer?
Well, for one thing, it's incredibly small. Current estimates put its diameter at just 5 miles, or about 8 kilometers. That makes it a strong contender for the title of smallest of Uranus's now 28 known moons.
5 miles. That's minuscule on a planetary scale. To put that in perspective, that's shorter than running a 10K race. How on earth did they even spot something so tiny, so far away?
With a very powerful telescope and a lot of patience. The discovery was made using the Magellan telescopes at the Las Campanas Observatory in Chile. The first sighting was on November 4th, 2023, but it took further observations to confirm its orbit and officially announce it on February 23rd.
And it's been given one of those classic, catchy astronomer names, I assume.
Of course. For now, it's carrying the temporary designation S/2023 U1. It will likely get a more permanent name later, traditionally from the works of Shakespeare or Alexander Pope, in keeping with Uranus's other moons.
I'll be waiting to see if it becomes a Juliet or a Puck. I also read that its orbit is huge. It takes 680 days to circle Uranus. That's a long year for such a tiny moon.
It is indeed. And this find is significant because it's the first new Uranian moon discovered in more than 20 years. It really underscores how much we still have to learn about the ice giants. They're distant, dim, and difficult to study from Earth.
It makes you wonder what else is hiding out there in the dark. A tiny body like this was probably a captured object from the Kuiper Belt, wasn't it? A visitor that got a little too close and was pulled into orbit.
That's the leading theory. Its distant, eccentric orbit suggests it wasn't formed from the same disk of material as Uranus's larger inner moons. It's a relic from the early solar system, now a permanent part of Uranus's family.
Well, from a captured moon to entire systems without a sun. Our next story is a real mind-bender. It's about rogue planets and the astonishing possibility that they can form their own moons.
This is truly a revolutionary idea, backed by some stunning observations from the James Webb Space Telescope. For our listeners, rogue planets, or as they're officially called, free-floating planetary mass objects, are worlds that drift through interstellar space, completely untethered from any star.
We used to imagine them as cold, dark, and solitary objects, but this new research suggests they might be the center of their own little solar systems. JWST observed 8 of these rogue planets in the nearby Orion Nebula.
And it didn't just see the planets themselves. It saw that they were surrounded by disks of gas and dust. What's more, the telescope's instruments detected the chemical signature of crystalline silicates within these disks.
And that's important because
That's the very same material we see in the protoplanetary disks around young stars. It's the raw material that clumps together to form planets, moons, and asteroids. Finding it around a rogue planet is a huge surprise.
So you're saying these starless planets have their own proto-moon disks, that they're basically acting like miniature suns, gravitationally gathering material to build their own satellite systems.
That's exactly what the evidence points to. These disks could, and likely will, coalesce into moons and perhaps even ring systems, all orbiting a planet that has no star. It creates a whole new class of celestial object, a rogue planetary system.
Wow, that fundamentally challenges our models of system formation. We've always put a star at the heart of that process. The star's gravity and energy were thought to be essential.
It seems the fundamental physics of accretion might be more universal than we thought. Gravity is the key ingredient, and it seems a planet sized object has enough of it to start building a family of its own. The galaxy could be teeming with these dark, wandering systems, completely invisible to us until now.
From lonely wanderers, let's come back closer to home for a story about family. Two of the most famous asteroids in recent memory, Ryugu and Bennu, have been confirmed to be siblings.
This is the payoff for two of the most ambitious sample return missions ever attempted. Japan's Hayabusa 2 mission visited Ryugu, and NASA's OSIRIS-REx mission visited Bennu. Both successfully brought back pristine samples, and now we're seeing the incredible result.
And the results are conclusive. By analyzing the composition of the return samples, scientists have confirmed that both of these carbon-rich, top-shaped asteroids are fragments of the same, much larger parent body.
So somewhere, long ago, a giant asteroid got hit by something else in a catastrophic collision and shattered. And Ryugu and Bennu are two of the pieces that went flying.
Precisely. The mineralogy and chemical makeup are just too similar for it to be a coincidence. But what's really exciting isn't just that they're related, but what they're made of. This is where it gets really interesting for us here on Earth, right?
Absolutely. Both samples are rich in water-bearing clay minerals. That tells us their parent body once had a lot of water ice. And even more importantly, they are packed with a wide variety of organic molecules.
Amino acids, the building blocks of proteins, the very stuff of life.
Exactly. This discovery provides powerful support for the hypothesis that asteroids and comets acted as a cosmic delivery service for the early Earth. They could have delivered both the water for our oceans and the complex organic compounds necessary to kickstart life.
So when we look at these two sibling asteroids, we could be looking at the same type of object that gave Earth its starter kit for life. It's like finding the delivery truck that brought the ingredients for the first ever cake.
That's a great analogy. It reinforces the idea that the ingredients for life aren't necessarily rare or unique to Earth, but are widespread throughout the solar system, just waiting for the right conditions.
Well, speaking of that cosmic delivery service, our final story today zooms in on one very specific delivery truck, the Devil Comet, and it's carrying a very precious cargo.
Yes, the comet, officially named 12P Pons Brooks, has been putting on quite a show for astrophotographers. But for planetary scientists, the real show is what's inside the water vapor it's releasing as it nears the sun.
Using incredibly sensitive instruments like the Atacama Large Millimeter Submillimeter Array, or ALMA, and NASA's Infrared Telescope facility, researchers have been able to analyze that water, and they found what many have been searching for decades.
They have. The water in Comet Pons Brooks has an isotopic signature that is a near-perfect match for the water here on Earth.
Okay, let's break that down. An isotopic signature is like a chemical fingerprint, right? It's about the different flavors of hydrogen atoms in the water molecules.
That's a good way to put it. Specifically, scientists measure the ratio of deuterium, a heavy version of hydrogen, to normal hydrogen. This is known as the D to H ratio. For a long time, the comets we were able to measure had much higher D to H ratio than Earth's oceans, which made the cometary delivery theory a bit shaky.
Right, the fingerprints didn't match, so scientists started looking more towards asteroids as the primary water source.
Exactly. But this new measurement from Pons Brooks changes the story. It's a Halley-type comet originating from the icy Oort cloud, and its water is virtually indistinguishable from ours. The fingerprint is a match.
So this single comet provides the strongest evidence yet that its ancient relatives are the reason we have oceans. Billions of years ago, a relentless bombardment of comets like Pons Brooks could have painted our dry, rocky planet blue.
It makes the cometary origin of Earth's water a leading theory once again. It doesn't mean asteroids didn't contribute. It was likely a combination of both. But this is a huge piece of the puzzle.
It's incredible to think about. Every time you have a glass of water, you might be drinking the remnants of ancient comets that traveled for billions of years across the solar system. That's a truly cosmic connection.
And what a profound thought to end on. That's all the time we have for today on Astronomy Daily. We've journeyed from a new moon around Uranus to the very origins of the water on our own planet.
It's been another day of incredible discoveries that remind us just how dynamic and interconnected the universe is. Thank you so much for joining us.
For more details on all today's stories and links to the original research, be sure to visit our website at astronomydaily.io. We'll be back tomorrow with more of the latest news from across the cosmos. Until then, I'm Anna.
And I'm Avery. Keep looking up.